Okay. So welcome everybody to the second technician class. How did everybody's last study go? Any immediate questions before we start the review?
I thought it was interesting that everywhere in the book it talks about, kind of metric and meters and everything else, but there were some questions, not very many, that suddenly jumped into feet, especially around inches. Yeah, especially around like antennas. It's like, why don't we just stick with one? And if you have to do it, convert at the very end.
Yeah, that's Marcanos. Got to be different. One thing that I will acknowledge is that I think Dave Kassler said it really good. Don't overthink this chapter. Um, Keep it simple. Just go with the flow and don't try to um, roll it all up because there's some new things that are coming tonight and um, it's really simple if we just go along with the building the layers of the components and the Ohm's law and resistance and all of that stuff. So um, we'll go ahead and get started.
Jim, this is Daniel.
Yeah.
And I want to reiterate that saying there's very few trick questions. As we come through it, I'll try to point the trick questions out to you, but there's very few trick questions in this database here for the question. So don't overthink it. Generally, your first response is going to be correct. What we're going to do is emphasize the correct answer so it stands out from the disclaimers and the false answers. So back to you, Jim.
And actually, Daniel, this slide deck that I pulled down from the ARRL, it's kind of teaching and the questions, but they don't put all of the questions. They just give you the right answer. So this slide deck, I have not gone in and edited. So as soon as we get to the review of the questions, it doesn't even give you the distractors. It just gives you the correct answer.
Jim, I was going to say one thing that really helped me to review was go to arrlexamreview.appspot.com, and it's really slick. So
yep. And that builds you a custom test, and you'll get, like you were going to a real test session. They'll take the correct number of questions for each section out of the question pool and create a customized test for you to practice on.
Yeah, it's pretty slick.
Yep. Okay, let me pull up the first slide and first module get going here. There. Let me get rid of this, put that over here. So this is chapter 3, the first section A. And there's additional resources up at the ARRL shop. And so we'll get right into it. Chapter 3, lesson module 3A for electricity. Fundamentals of electricity. Radios are powered by energy, and radio signals are a form of electrical energy. A basic understanding of how we control electricity allows you to better install and operate your radio. Electrical charge can be positive or negative. Opposite charges attract each other. Electrical current is the flow of electrons. Electrons are negatively charged atomic particles, usually surrounding an atom's positively charged nucleus of protons, the positive, and neutron, neutral or no charge. I had somebody join us. Move this over. Sorry, I heard somebody join us. And I can't see who it
That was
is.
just me.
Oh, it was
It
you.
was just me, Daniel.
Okay, sorry. Okay. Electrons move in response to an electromotive force and can move independently of atoms. Basic electrical concepts. Current, the movement of electrons measured in amperes, the letter A, by an ammeter and represented by I in formulas. Voltage is the amount of electromotive force, or EMF, also called electrical potential, measured in volts with the letter V by a voltmeter, represented by E or V in formulas. Resistance is the opposition to the movement of electrons measured in ohms with the Greek capital omega and by an ohm meter represented by R in formulas. Resistance is like friction and turns electrical energy into heat when current flows. Conductors permit current flow, low resistance, and insulators block current flow or high resistance. The flow of water through a pipe is a good analogy to understand the three characteristics of electricity and how they are related. Voltage from a source of electrical energy causes current to flow. Resistance is a material's opposition to the flow of current. Voltage, current, and resistance affect each other. For example, higher voltage, a bigger push, causes more current and more flow. Two kinds of current. Current that flows in only one direction is called direct current, or DC. Batteries are a common source of DC. Current that flows in one direction, then in opposite direction, is called alternating current, or AC. Household current is AC. AC current reverses direction on a regular basis. Each process of reversing is called a cycle. The number of cycles per second is frequency and is measured in hertz, or Hz. 1 hertz is equal to 1 cycle per second. The electronic circuit, an electronic roadmap. For current to flow, there must be a path from one side of the energy source to the other side of the source. This path is called a circuit. There must be a pipe or a conductive path through which the water or the current can flow. There are two types of electric circuits, series and parallel. A series circuit. Series circuits provide one and only one path for the current to flow. Parallel circuits. Parallel circuits provide multiple paths for the current to flow. Okay, so now we're going to jump into the practice questions. For these, let's as you think of the answer, go ahead and unmute and yell out the answer. Electrical current is measured in which of the following units? What's the measurement for electrical current? Go ahead and unmute when you're.
Is that amps?
Amperes, yep. That's T5A1, A01, page 3-1.
And sometimes it's called amps, AMP, they shorten it up, yes.
What is the name for the flow of electrons in an electrical circuit? That would be current. And that's on page 3-1. What is the name for the current that flows only in one direction? One direction
Direct current.
is direct current, correct. And that's on page 3-2. What is the electrical term for the electromotive force, EMF, that causes electrons to flow? Electromotive force that causes electrons to flow is voltage, and that's also on page 3-1. What is a good electrical conductor?
Copper. Copper.
Copper is correct, and that's on page 3-5. What is a good electrical insulator?
Glass.
Glass is correct. That's also on page 3-5. What is the name for a current that regularly reverses? What is the name for a current that reverses direction on a regular basis?
Alternating current.
That's correct. Alternating current on page 3-2. What is the unit of electromotive force? EMF, electromotive force,
Volt.
is the volt.
Really?
Yep. That's on page 3-2. What describes the number of times per second that an alternating current makes a complete cycle? The number of times per second
Hertz.
is the frequency, and it's measured in hertz. Yep. Which instrument would you use to measure electric potential or electromotive force?
Voltmeter.
A voltmeter, that's correct. Page 3-2. What is the correct way to connect a voltmeter to a circuit?
Is that in parallel?
That is in parallel with the circuit. Yep. Page 3-3. How is a simple amp meter connected to a circuit? That would be in series with the circuit. Page 3-3. Which instrument is used to measure electric current?
Ammeter?
Ammeter. Yeah.
An ammeter, that's correct. Page 3-3. What instrument is used to measure the resistance?
Ohmmeter.
An ohm meter on page 3-5. Yep. Which of the following might damage a multimeter? What would damage a multimeter?
Incorrect connection.
Attempting to measure voltage when using the resistance setting. Yep. Page.
Almost everybody has done that, by the way.
Yep.
So when you hook it up, be sure that if you're measuring ohms or resistance, you're on the resistance scale and the circuit is not powered. If you're measuring voltage, make sure it's on the volt scale. Double check it before you put the meter onto the circuit.
Yep. And I was also going to mention in one of my other voltmeters, this one has a definite off position so that you don't blow things up. But what I used to do, see how the ohms are right beneath the hold button. What I would do, I would always make sure that whenever I left my voltmeter that didn't have an off position, I would always leave it in a voltage that was the highest rating, just so that I knew that I wasn't going to blow something up. So I would always put it to the 500 volts AC. That way, if I ever happened to turn it on, I wasn't going to blow something up. But luckily, this one has a definite off to make sure that I don't screw something up. So yeah, always make sure that there's no power to the circuit when you're measuring resistance.
And did they say in one of the sections about you will see a change in resistance if you hooked it up to when there's a capacitor there because it had a residual charge? And
Yes,
so the essentially is powering the circuit at that point.
Yeah, if you have a high capacity capacitor, it will discharge through the circuit when you put the meter on there. But you'll see the resistance start to change and increase, and you have to wait till it fully increases and stabilizes before you get the true reading. Yes.
But that wouldn't necessarily damage the multimeter then?
Generally not, unless you're into high power voltage circuits, which should have a bleeder resistor in there in a way. But on the normal receiver transmit circuits, you're not going to blow the meter up. What happens here is in the resistance setting, you have like a 1.5 volt battery, and that power puts power into the circuit. If you have another power source, you're going against that 1.5 volt battery. You can actually blow the battery up and destroy the meter.
Got it.
Yeah, and a lot of the better constructed voltmeters will have a fuse on the inside too when they're going to measure the resistance so that you don't blow things up. Which of the following measurements?
Is anyone else having issues with? I'm sorry.
Go
Is
ahead.
anyone else having issues with audio? I'm getting a lot of feedback. Is it just me?
Audio is good for me.
Yeah,
Not
it's,
at this end, it's
Oh.
fine.
Sounds fine to me.
yeah, it's good for me too. And I did mute my extra laptop here too.
Okay, maybe it's just on my end.
Sorry, Harrison. I don't know. Okay.
Carry on.
Okay. Which of the following measurements are commonly made using a multimeter?
Amperes, voltage.
Voltage and resistance. A multimeter has the two built in for measuring voltage and resistance.
The third one is the current, but it's harder to measure current because you have to interrupt the circuit, make sure all the current goes through the meter. Multimeters can measure current, but it's harder to do it. So the most common you use them for are the voltage and the resistance.
Okay. What precautions should be taken when measuring circuit resistance with an ohm meter? We just talked about that. We want to ensure that the circuit is not powered. Page 3-4. Which of the following precautions should be taken when measuring high voltages with a voltmeter? So measuring high voltages with a voltmeter, what precautions should you take?
Is that making sure the wires are the correct gauge that can handle it?
Yep. Ensure that the voltmeter and the leads are rated for the use at voltages to be measured. And that's why it's good to, when you get your meter out, make sure you know what range it's going to handle. So on this one, nope, get over there. So the highest voltage that I could do on this one is 500 volts AC. And then for the amps is, and you'll see in here where it's got a 10 amp max for the maximum rating. So be sure to check your meter.
Jim,
Yes.
what does the number on the plastic leads at the point of the wires indicate?
It indicates that I need better glasses because I can't read them.
Generally, that's like 500 or 1,000 volts, and that's generally
Yeah.
not enough. Those little plastic tubes at the end of the leads,
Uh-huh.
you have to have those rated at the proper voltage too.
Yeah. Okay, yeah, it says 10 amps on the lead. No, it's not going to zoom in on that.
Almost see it. What's the voltage rating though?
Yeah,
10
so
amps. I see the 10 amps.
yeah, it sees the 10 amps, and I don't see a voltage.
And Jim,
Yeah.
I was going to say the other answer you may want to throw in there is to make sure that you're not part of that high voltage circuit. You're not
Yeah.
touching it.
Yeah. One, like Robin says, make sure you are not part of the circuit. And the best way to do that is to work with just one hand behind your back. That way you're never going to complete a circuit. It's still easy if you're barefooted, but yeah, try to work with just one hand. So it looks like we have a new person that just joined in. Butch. Hello, Butch. Can I hear who Butch Biggins is? Hello. Alrighty, moving on. Okay. Oh, that's the end of Module 3A. Alrighty. So, any questions on that Module 3A? Okay, hearing none, let's jump into 3B. So 3B has the similar first two pages. So in Module 3B, we'll cover Ohm's law, power, and the metric system. Ohm's law, and you'll see that it's in the shape of a pie. Half of the pie is E, and then 1/4 is I, and the other quarter is R. So one thing that my electronics instructor told me to do was draw this immediately when you sit down and they say that you can start your test. Draw this little symbol, and the shape of a pie with half of the pie equals E on the top, and then the other quarter I and the other quarter R. And you'll be able to, if you're wanting to solve for, let's say we're going to solve for E, put your thumb over the E and you see that the I and the R are down there, and that would be I times R. Put your thumb over the I and you'll see that you're going to divide the E divided by the R. And then if you're going to solve for the R, you would take your thumb over the R, and that would be E over I. So we'll go into that. E represents the voltage units, and the unit is volts or V. I represents current units, measured in amperes, or A. R represents resistance. The units is ohms, or the Greek symbol omega. R for resistance is equal to E over I, or E divided by I. Current I is equal to E divided by R. And E voltage is equal to I times R. Practice questions. So we're going to be doing a lot of practice questions using the basic math. So just on page 3-5, you'll see that little pie chart again. So if you have your book handy, look at chapter or page 3-5, or you can draw a pie and put half of the pie on the upper part with the E, a quarter to the pi I, and a quarter to the pi R. Oops, went too fast. What is the formula? What formula is used to calculate the current in the circuit, or I?
E divided by R.
Current is equal to E divided by R. That's correct, page 3-5. What formula is used to calculate the voltage in a circuit? What was that?
E times R.
Yep, E
Times R, sorry.
equals I multiplied by R, I times R. What formula is used to calculate resistance in a circuit? So cover up the R and we have E divided by I. So now we're going to get into using the math. What is the resistance of a circuit in which a current of 3 amps flows through a resistor connected to 90 volts? So 90 is going to be the E, and 3 is going to be the I. So cover up the R. We want to do the E divided by I. So 90 divided by 3 is 30 ohms. A lot of math, basic math things now. So what is the resistance in a circuit for which the applied voltage is 12 volts and the current flow is 1.5 amps?
Jim,
Yes.
it's Daniel. If you put the 12 volts by the E and the 1.5 amps by the I, you'll see that the volts are over the amps and it's going to be a divide.
Yep.
And that will help you out. You're only going to use the E over IR circle once in the technician test. So go ahead and put the 12 volts by the E and the 1.5 amps by the I, and that'll give you a good visual as to how to do the math.
Cool. So 12 divided by 1.5, handy dandy calculator, had some fingers in there, is 8 ohms. What is the resistance of a circuit that draws 4 amps from a 12 volt circuit? So like Daniel said, put the 12 on next to the E on the top and the 4 next to the I on the bottom. So 12 divided by 4 is 3 ohms. What is the current flow in a circuit with an applied voltage of 120 volts and a resistance of 80 ohms? So like Daniel says, we'll put 120 next to the E and a resistance of 80. So put the 80 next to the R. So it would be 120 divided by 80. That is 1.5 amperes. It's on page 36. What is the current through a 100 ohm resistor connected across 200 volts? So we're solving for I. So take the 200 volts and put that next to the E, and the 100 and put that next to the R. So 200 divided by 100. Is 2 amperes. What is the current flow through a 24 ohm resistor connected across 240 volts? So 240 goes next to the E and 24 goes next to the R. So 240 divided by 24. And the answer is 10 amps. I heard somebody unmute. We're getting close. What is the voltage across a 2 ohm resistor if the current is 0.5 amperes flow through it? So this is put the 2 next to the R and the 0.5 next to the I. So 0.5 times 2. The answer is 1 volt. Yep, page 3-6. What is
And
the
that's
volt?
basically how the math goes. It's fairly simple math.
Yep.
Most of us can do that in our head, but calculators are allowed.
Basic calculators with no memory left in it. Or no, what do they call it? Not those programmable calculators. What is the voltage across a 10 ohm resistor if the current of 1 ampere flows through it? So 1 is next to the I and 10 is next to the R. 10 times 1. Bingo, 10 volts.
Now,
What?
cell phones or iPads are not allowed for calculators, by the way.
Yep. Anything that has access to the internet is a no-no. What is the voltage across a 10 ohm resistor if a current of 2 amperes flows through it?
Mm. 20 volts.
20 volts, winner. That's page 3-7.
Thank you, Vanna.
Power, electrons doing work and expending energy. So now we're going to get into the, on page 3-5 has the additional pie chart. Anytime energy is expended, power is consumed. Electrons moving through resistance expend electrical energy and consume power. Power is the rate at which energy is consumed. Power is measured in units of watts, or the capital W. The power equation. Power is calculated as the product of voltage and current. And here's our magical pie chart. So P is power, is the half on the top, and I on the left side, the quarter of the pie, is current, and E is the voltage. So P equals E times I. Put your thumb over that P on the top, and you see that it's I times E. If you're solving for E, or voltage, put your thumb over that E, and you'll see that it's P divided by I. If you're solving for the current or I, put your thumb over that I, and then you'll see that it's P divided by E. Like Ohm's law, if you know the two values, you can calculate the third. Now on to the practice questions.
Jim?
Yeah.
What we like to see you do is write these two formulas down on your scratch paper when you start.
Yep.
It's like giving a couple free questions to you. It takes the stress out of these math questions. A lot of people haven't been in school for a long time, and math kind of is they panic on it. Write these circles down on your scratch paper. It really helps out. We found the students that did that got better grades.
I did that immediately. As soon you have to wait for them to say, okay, you can start the course, but even before, as soon as they say that you can start, take your scratch paper and draw those two circles right away. Then open the book and, like Daniel say, I was going, bing, there's the answer right there. Very good. So let's get the practice questions. Electrical power is measured in which of the following units? So what is the unit for measuring electrical power?
Is that watts?
Watts. That is correct. Page 37. Which term describes the rate at which electrical energy is used? The rate that it is used is power, which is measured in watts. What is the formula used to calculate electrical power in a DC current? That is the power equals a voltage multiplied by the current. So cover up that P for power and you have the I times E. How much power is being used in a circuit when the applied voltage is 13.8 volts DC and the current is 10 amperes? So 13.8 would go next to the E and 10 would go next to the I. So I times E is 138 watts. How much power is being used in a circuit when the applied voltage is 12 volts DC and the current is 2.5 amps? So the 12 goes next to the E and the 2.5 goes next to the I. So 2.5 times 12 is 30 watts. How many amperes are flowing in a circuit when the applied voltage is 12 volts DC and the load is 20 watts? So this time we're going to take the 120 and that'll go next to the P, and the 12 volts DC will go next to the E on the bottom. So 120 divided by 12, 10 amps. Metric prefixes. So here's our table for the metric prefixes. And the largest is tera, walking down to giga, mega, kilo, hecto, and deci. And those are all 10 to the 12, 10 to the 9, 10 to the 6, 10 to the 3, 10 to the 2, and 10 to the 1. And then we go into the smaller portions, deci, centi, milli, micro, nano, and pico. And you can see all of those 10 to the negative 1, 10 to the negative 2, etc. down the list.
And that's on page 2-2.
Okay. Electrical units. The electrical units and their namesakes are who they were named for. Look at all these guys, all in the 17 and 1800s. Ampere measures current, and that was Andre Marie Ampere. Coulomb measures the charge, and that was Charles Augustin Coulomb. Faraday measures resistance, that was Michael Faraday. Henry measures inductance, and that was Joseph Henry. Hertz measures the frequency, and that's Heinrich Hertz. Ohms measures resistance, and that was George Simon Ohm. Watt measures the power, and that's James Watt. And volts or voltage is Alessandro Giuseppe Antonio Anastasio Volta. Wow, that's a long. Guy's got a nice long name there.
When you got coulombs and you got Faraday and Henry, the capacitor and the inductors have special resistance it gives to alternating current. That's why there's a little different than just ohms. Ohms is resistance to all AC or DC current, direct or alternating current. But the capacitor and the inductor offer special resistance to AC current, alternating current.
Okay.
Will any of these be on the technician test, or this is just information that's good to know?
They'll be on the test.
Okay.
Not the names.
Yeah, not the names. Just don't worry about remembering the names. Just remember that amperes is for current, Coulomb is for the charge, Farad is capacitance, Henry is inductance, Hertz is frequency, Ohm is resistance, Watt is power, and Volt is voltage. All right, on to some practice questions. Be sure to unmute and shout it out. How many milliamperes is 1.5 amperes?
So 1500.
That is 1500s.
On this section, you're moving at 3 decimal places and sometimes 6.
Yep. So jump over to Robin mentioned page 2-2, and it's got all of the prefixes there. What is another way to specify a radio signal frequency 1500000 hertz? What is another way of specifying that? What would it be in kilohertz? Yep. So move the decimal 3 places over. That would be 1500 kilohertz. Another way of saying that would be 1.5 megahertz. So you'd move it 3 more over. So like Daniel said, it's mainly moving the decimal points over 3 places. How many volts are equal to 1 kilovolt? That would be 1000 volts. How many volts are equal to 1 microvolt? So micro is going into the smaller direction, and that would be moving it over 3 places. So that would be 1/1,000,000th of a volt. If an ammeter calibrated in amperes is used to measure a 3000 milliampere current, what reading would it show? That would be 3 amps, so we'd move the decimal place over 3. If a frequency readout calibrated in megahertz shows a reading of 3.525 megahertz, what would it show if it was calibrated in kilohertz?
5,000.
3525.
Kilohertz, that's correct. How many?
Jim, go back to that question.
Okay,
3525 kilohertz is where the general privileges start on the 80 meter band. The first 25 kilohertz are reserved for extra. So some of you guys are taking the general class, and on 80 meters, 40 meters, 20 and 15, you're going to see the first 25 kilohertz missing on your privileges questions. That's reserved for extra CW operators. So that's where the general privileges start on the 80 meter band. Go ahead, Jim.
Daniel, is that just for Morse code?
Yeah, the first 25 kilohertz, that's Morse code. The Morse code had first choice, so it chose the bottom portion of the bands because on the HF bands, the lower frequencies go further. So they chose the lower frequencies. The voice people got the higher end. It doesn't go quite as far typically.
cool. How many microfarads are 1,000,000 picofarads? 1,000,000 picofarads. That would be 1 microfarad. So you'd move that 6 picofarads is 6 off. Micro is 3 off. 3 positions for the decimal point. If a frequency display shows a reading of 2425 megahertz, what frequency is that in gigahertz?
2.425. Okay, too slow.
Yep. No, you got it. I was click. We were having a speed race with my finger and your answer.
This is part of the Wi-Fi band. The first 6 channels are amateur, and we're not limited to 4 watts like everybody else on part 15 devices are. We can run power on these devices, and their machines or computers have to wait till we finish talking because
Oh, really?
you've got the channel.
Oh, really?
You laugh about that because we're going 30 miles on 5.8 gigs when you, on the G channel with our ham internet. So it's yeah, we do have privileges.
To the areas.
Yep. And that brings us to the end of module 3B. Any questions for this particular module? We have 2 more to go.
Jim, let me go on to this here. We started HamWAN about 7 years ago. HamWAN is an amateur internet that crosses Washington from Vancouver, BC to Portland to Spokane to Tri-Cities area. The pattern we have chose here has gone across the nation and around the world. The amateurs have their own internet network. And so when the worldwide internet goes down, we will still be able to use our own internet to communicate.
Yep. So here's what Daniel was talking about. This is the HamWAN Puget Sound data ring, and it goes actually all the way up to Canada.
Daniel, how many repeater sites are there for that?
Well, I've been on 14 of them. But, we have on the DMR, we have over 55 repeaters in the network here in Washington. So yeah, we have lots of high sites covering that in.
So
how many are backed up with generators / batteries?
All of them.
Good.
Yep.
What they did on Baldy, which is out of Enumclaw, they double the amount of batteries they normally have, and then they double that again. So they got 4 times the battery backup they normally have. That's 4,000 foot high mountain. And if the snow comes in, they lose power. They can be without power for a week, and our radio gear or our internet will still be functioning.
Are they
Yeah.
double backed on other pre-existing towers, or do they have their own?
They're on commercial towers most of the time.
Okay, thanks.
Yeah, but we have a lot of battery backup, and sometimes they have a couple of sources of internet up there in Baldy. There's 2 sources. It's tied to what they call gateway. So our amateur internet is tied to the worldwide internet through a gateway, and there's 2 sources there. And there's also, I think there's 2 sources there in Bellingham.
Mhm.
So they've
Well,
they
look,
got redundancy. which
it
is
looks
what they
like
call
in
farming.
Bellingham down in Olympia, and 2 other places like Seattle, and I can't see Whidbey. Looks like there's 3, like a triangle of 3 dots around each of them in those places.
Yeah,
those
they have
are
3
sectors.
sectors pointing 3 different directions.
Got it. Okay, thanks.
That's what they can consider a full site. They got 120-degree antennas pointing 3 different directions. So you're going to have the sectors pointing out. We've got Lars Mountain and Vancouver, Washington. You got Bafa out of Centralia, 12 miles west of Centralia. You've got Olympia, which is the Capitol Forest and Capitol Peak. You've got Bellingham and Gold Mountain. You've got a couple of Seattle sites. You've got Fraley up out in Snohomish, and you got Lookout there out of Bellingham. Those are the mountain peaks.
Cool. And can you join that to get all the frequencies and so forth?
Right. Just Google Hamwan and you'll get into it.
Great, thank you.
Hamwan.org.
It's a 501, supported by members, and it has a board like that.
I put the link in the chat for those that are interested.
Thanks, Jim.
Okay, so let's jump into module 3C. This module will cover electrical components. Electronics controlling the flow of current. To make an electronic device like a radio do something useful like a receiver, we need to control and manipulate the flow of current. There are a number of different electronic components that are used to do this. Schematic diagrams. Schematic diagrams can draw pictures of electronic components forming circuits, such as for the parallel and series circuit examples. This is too cumbersome for most circuits. So schematic diagrams have symbols with different components, each having a different symbol. The lines and the dots on schematics represent electrical connections between components. So here's the electrical connection, and then you see the little dot right here.
The other thing, Jim, here is you read this from the left side to the right side. The signal comes from the left and comes out the right side.
Yep, so
Input.
comes in this direction, input signal, and goes out this direction to the amplified signal. The resistor. The function of a resistor is to restrict the flow of current. The schematic symbol, let me bring that up. The schematic symbol is little wavy lines. Remember Ohm's law, I equals E divided by R, or voltage E equals I times R, and this is a picture of a resistor with the color codes for the value. So the squiggly lines is a schematic for a regular resistor. A squiggly line with an arrow pointing is a potentiometer, and that's an adjustable value of a potentiometer and is used for like controlling the volume.
The potentiometer is also called a variable resistor.
Yep. The capacitor. The function of a capacitor is to store electrical energy called capacitance. The schematic symbol is this one here where it shows 2 plates for the electrodes, and this is a variable capacitor with an arrow through it. And then this is what a capacitor, a ceramic capacitor looks like. And it'll tell you the value is 100 plus or minus 10, and its rating is 1 kilovolt.
The capacitor does not let DC current go through it, but it does pass alternating current.
The schematic symbol is over here, and it acts like a battery. It stores energy in an electric field created between the electrodes with insulating dielectric in between them.
I thought the capacitors were measured in farads. Why does it have 1 kV then?
And that's just the voltage rating is
Too much voltage can burn up the capacitor.
yeah,
Oh, okay, so the 100 is the 100. Is that 100 farads?
that would be microfarads most likely in this, because it's a small one. The inductor. The function of an inductor is to store magnetic energy called inductance. A coil of wire around a core of air or magnetic material like iron or ferrite. So this one has an air core, and this one has a little ferrite ring. And it stores energy.
You want to describe what ferrite is?
Ferrite is like a magnetic material or semi-magnetic material. It helps keep the magnetic energy within that circle.
Yep.
It's iron.
Yeah. And it stores the energy in a magnetic field created by the current that goes through the wire. And the schematic symbol is a line with little loops in it. And if it's a variable, then it will have the little arrow through it. And the function of an inductor is to store magnetic energy called inductance. A coil of wire around a core of air or magnetic material like iron or ferrite, and it stores energy in a magnetic field created by the current in the wire. The transformer is a
I had
pair.
a question about that. I mean, it might be a bit onwards, but does it really store energy? I thought the magnetic field only existed when there's current flowing. As soon as the current stopped flowing, there was no magnetic field.
It will have a magnetic flow through it as long as there's current in the wire.
So then why does it say it stores energy? Is that because there's some, like, I associate storage with some sort of battery or something that persists.
It's keeping the magnetic flow in the core
Mhm.
as long as there's current in the wire, and then as that current dissipates, that takes whatever magnetic energy is left in that field and tries to keep it. So it is kind of storing it,
Oh, I see.
but then it dissipates because it doesn't have anything to keep it going.
Yeah, it's storing is kind of a funny term there. The capacitor is actually acts like a battery and does store, but the inductor, it stores it from one positive side of the alternating current to the other side, and that's where the resistance comes in. But when you take the current off, whenever you change the current through an inductor, it's going to spike a voltage and discharge. But storing the energy is kind of a funny concept with inductor. Yes.
Yep.
Yeah, Tony, it basically exists while the other is existing. So
Right, thanks.
Okay. The transformer. The transformer is a pair of inductors that share a common core, And here's the schematic symbol. You get the two little loops, and then here's a core that it shares with the other magnetic loops, and this is what a transformer looks like.
The inductor looks kind of like a slinky, kind of a rounded edges. The resistor has sharp points. So that's the difference between the inductor and the resistor.
Okay. They also share the magnetic field, and it's used to transfer energy from one circuit here, and it transfers the energy to the other circuit without a direct connection. And it changes the ratio of voltage and current. Electrical units. Each type of component has a value measured in specific units. Resistors measure resistance and is measured in units of ohms. Capacitors have capacitance and is measured in units of farads. Inductors is a measurement of inductance and is measured in henries. Component designators. Each schematic symbol has a designator to denote which component it refers to. For example, the 10th resistor in a circuit is R10. Resistors labeled with a capital R, capacitors labeled with capital C, and inductors labeled with a capital L. Indicators and displays. Indicators communicate the status: on, off, ready or standby, left or right. LEDs, light bulbs, symbols, and audio tones. Displays communicate values or text: numeric values, warnings, messages. Digital and analog meters, LCD screens. Reactance. Capacitors and inductors store energy rather than dissipating them like resistors. Energy storage creates an effect called reactance, the symbol is X, that acts like a resistance in opposing the flow of alternating current or AC current. Capacitors create capacitive reactance or X sub C. Inductors create inductive reactance or X sub L. The effect of each are complementary. The impedance. The combination of resistance, capital R, and reactance, capital X, is called impedance, represented by the symbol Z. Impedance represents a circuit's opposition to both AC and DC currents. Resonance. A component's reactance depends on frequency. X sub L increases with frequency, while X sub C decreases with frequency. At the frequency for which a circuit's X sub L and X sub C are equal, their effects cancel. This is the circuit's resonant frequency. At resonance, a circuit has only resistance, which affects AC and DC currents equally.
Sometimes we call that DC resistance.
Okay. Resonant or attuned circuit. Capacitors and inductors connected together create a tuned circuit. When X sub L and X sub C are equal, the circuit is resonant. If C or L are adjustable, the resonant frequency can be tuned or varied.
This, by the way, Jim, this allows the radio to select one channel over another channel and reject the other channels. This is a very important concept to letting everybody talk on the radio at one time, and you only listen to one party or one channel at a time. This resonance concept is how we do that.
Okay. Semiconductor components. They're made of material like silicon that are okay conductors, but are not as good as metals. Impurities added to semiconductors create material with more than usual electrons that are the N-type and fewer than usual P-type electrons. The structures of N and P material can control current flow through the semiconductor. The diode allows current to flow in only one direction. The schematic symbol is this here, and the designator is D or CR. Two electrodes, one is the anode and one is the cathode. Here's the anode side and here's the cathode side on each one of these. AC current is changed to varying pulses of DC. This is called rectification. Diodes used to change AC power to DC power are called rectifiers.
A diode is basically like a one-way street. You only drive down the street one direction. You're not supposed to drive the other direction.
And here's the symbol. It's one direction only. It's the arrow pointing that direction. That's the way the current was flowing.
Actually, the current goes the other direction. The current goes against the arrow. The arrow is like a dam. The current can go over the dam. The arrow comes up to the dam and stops. They had a 50% chance when they chose the direction of that initially, and they got it wrong. But the electrons come from the cathode side over the dam and down the stream and out to the ocean. So that wall is a dam that stops the flow of current.
It's kind of counterintuitive if you go by the arrow.
I spent a lot of time in Alaska, so I think about the dams and the river and the waterfalls, and so the fish can go over the waterfall out to the stream to the ocean, but they can't come up and jump the waterfall going upstream.
Yeah, that helps.
Okay. The transistor. The function of a transistor is to control large signals with smaller ones. An electronically controlled current valve. The schematic symbol is this for a bipolar junction transistor, or this symbol for a field effect transistor. When used as an amplifier, a transistor produces gain. Transistors can also be used as a switch. The bipolar junction transformer BJT has 3 layers of N or P material connected to electrodes. So you have a collector, a base, and an emitter. Depending on the arrangement of the layer, the BJT is either an NPN or a PNP, and it's designated by the direction of this little arrow that you see here. One of the little tricks that my instructor told us, if you want to look at the arrow, if it's not pointing in, it's an NPN. This is not pointing in, so this is an NPN. If it's pointing in the other direction, then it's a PNP. The field effect transistor, the FET, has a conducting path or a channel of N or P material connected to the drain and source electrodes. So this is the other transistor that has a drain, a gate, and a source. Voltage applied to the gate electrode controls the current through the channel.
So an FET has both materials of N and P, where the other one only has N or P. Is that right?
No, each one of them has the three materials, either a PNP or an NPN. They'll
But
both
this
have.
has both.
This has both N and P.
Yeah, that's what I was saying, I think.
There are three different languages in here. The tube has one set of languages. The plate, the grid, and the emitter. Then you got the bipolar with the collector, base, and emitter. And you have the FET, which is a drain, gate, and source. They kind of all do the same thing, but there's three different languages. Each one has its own language. Go ahead.
Yeah.
Clear as mud.
So the current would move from the source through to the drain, but the gate is controlling it.
Right.
And then, conversely, it's the emitter being controlled by the base goes to the collector. Yeah.
Yeah, Jim, what I was referring to is in the slide you have up right now at the bottom, it says NPN or PNP. The next one, your FET, has both elements there. And
Yeah. N and P also.
Yeah. Okay.
The integrated circuit. The integrated circuit is a collection of components contained in one device that accomplishes a specific task. The schematic symbol is usually a box or a triangle, and the designator is an IC or U. Protective components. Fuses and circuit breakers are designed to remove power in case of a circuit overload. The schematic symbol would be this little curly Q with two little dots, and then the circuit breaker would have a resettable component where you can push it back to reset it. Fuses blow once, so you'll see in this picture here, there's a little tiny wire, and as soon as that burns up, it goes out poof once and protects the circuit, but you cannot reutilize it. But a circuit breaker can be reset and reused. Always use the proper rating. Switches. Switches are used to interrupt or allow current to flow. And here are several different schematic symbols. This is for a single pole. Here's a single pole with a single throw, which means only one connection. Here's a single pole with two throws, or a double throw. Here's a double pole. You see that there's two poles and they're connected together, so they both operate at the same time. And then there's two positions or throws that it can go to. So this is a double pole, double throw. And then this is a symbol for a push button. Each circuit controlled by the switch is a pole. Each position is called a throw. Relays. Relays are switches activated by current in a coil or an electromagnet. The schematic symbol is this here. You have the coil, which is connected to your, or virtually connected to your relay or your common connection, and then it has a normally open and a normally closed. Relays use the same pole and throw names as switches. The moving switch is called the armature. Contacts are named by when they are connected. So you have normally open or a normally closed. And here's your huge, and I meant to have the page up. So I know this is on one of the pages here. So here's all of the symbols or schematic symbols, which is in the book on page 3-15. So we'll just go over these really quick. An LED has a diode symbol with the little arrows pointing off. A diode rectifier is a diode, and then you have a voltage variable capacitor, tunnel diodes, Schottky diodes has the little square, and the Zener diode has the little tabs off the end. And then this is bridge rectifier. These are all diodes in here. Then you have circuit interrupters. You have the
There are
fuse.
9 different diodes are on the extra test, but the only thing you will have to worry about is a light emitting diode or a regular diode on the technician test.
Okay, good. So that's just these 2 that you need to worry about. Circuit interrupters are the circuit breaker and the fuse. And then here's the batteries symbols. This is a multi-cell and this is a single. These are the symbols for the different grounds. And if they put a A, it's an analog ground, or D is a digital ground. And these are symbols for plugs and receptacles. These are all your resistors. This is a photoresistor showing the sun rays coming in. This is a variable resistor with a little arrow through it. This is a thermistor. This changes depending on the temperature. It'll change the resistance. This is a tapped resistor. It's kind of like a variable, but it doesn't move. It's only in one single place. There's the adjustable potentiometer or adjustable resistor, and this is the symbol for a fixed resistor.
A thermistor is used in a thermostat on the wall. And I think the only resistors you're looking here is a regular resistor or a variable resistor for the test.
Cool. So these are the 2 to look out for. How about in capacitors? Is it just the fixed and the variable, I bet?
Fixed and variable, yes.
Yep. So these would be the 2 in the technician, fixed and variable. But you'll also see electrolytics later on with a little plus side to let you know that that's where you put the plus. And this would be a non-polarized. And then a feed through and a split stator.
Let me mention on the electrolytic, the one that has a plus and a minus, that is a liquid filled capacitor that separates the two plates, so it's liquid. It's used in power supplies because it gets a high value of capacitance for a small package. So you'll find them there a lot of times they're either blue or black, or maybe they're silver, and they're 1/2 inch or bigger, tall, a couple inches tall sometimes. But they're used mainly in power supplies. So.
And here's the symbols for inductors. And if it has an iron core, this would be an air core without any lines through it. And then here's all of the different transistors. On the test, I think they're only showing the PNP and the NPN for transistors, and then they also have I think the FET. Is that the only ones on the test?
Yes.
Yeah, I think that was the only ones that they had on the test. And
Yeah, Jim, I was going to say that this circuit symbol diagram you have up on the screen is a little more complete than the one that's on page 315, but they're all pretty close.
Oh yeah, you're right. I do notice that yep. It is missing quite a few on 315.
But it won't affect the technician test at all.
Yeah. Thanks, Robin. So now on to the practice questions. What is the ability to store energy in an electric field called?
Is that capacitance?
That is capacitance, correct. What is the basic unit of capacitance? That is the farad. Page 3-9. What is the ability to store energy in a magnetic field called?
Inductance or inductor.
Yep, inductance. And it's what is the basic unit of inductance? That is the Henry. What is impedance? Impedance is a measure of the opposition to AC current flow in a circuit. What is the unit of impedance? The unit of impedance is in ohms. What electrical component opposes the flow of current in a DC circuit? Putting on the brakes to the flow of electric current is the resistor. What type of component is often used as an adjustable volume control?
Potentiometer.
Potentiometer. What electrical parameter is controlled by a potentiometer?
Is that resistance?
Got it. Yep. What electrical component stores energy in an electric field?
Capacitor.
Capacitor.
Should I stop? I don't know if I should.
You're winning. You're winning. You're winning. You're gonna get the entire column and the daily double. What type of electrical component consists of two or more conductive surfaces separated by an insulator?
Is that a capacitor?
You've got it. You're running capacitor for 500. What type of electrical component stores energy in a magnetic field?
Inductor.
Inductor for 100.
I'm not gonna mute. I'm gonna go out and mute again.
Keep going for it. What electrical component usually is constructed as a coil of wire?
Inductor.
Inductor.
An inductor for 200. What electrical component is used to connect or disconnect electrical circuits?
Switch.
A switch for 50. What electrical component is used to protect other circuit components from current overloads?
A fuse.
A fuse. What class of electric components is capable of using a voltage or current signal to control the current flow?
Transistor?
Transistors for 100 is correct. What?
Yeah, Jim,
Yes.
transistors are current devices where tubes are voltage devices, control the voltage. So that's kind of the basic difference between a tube and a transistor.
Okay. Thank you.
And transistors developed about a year or two after Roswell in 49 or so.
Oh, so that's alien technology.
If you try to look up the history of transistors, you don't get a whole lot of information.
What electronic component allows current to flow only in one direction?
A diode.
A diode for 200. Which of these components can be used as an electronic switch or an amplifier?
Transistor.
Transistor is correct. Which of the following components, oh, that was for 200, by the way. Which of the following components can consist of 3 layers of semiconductor material?
Also a transistor.
Ding, 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 the daily double. Transistor. Which of the following electronic components can amplify signals?
And 3 times the transistor.
3 times for the transistor. How is the cathode lead of a semiconductor diode often marked on the package?
With a stripe.
With a stripe, yep. What does the abbreviation LED stand for?
Light emitting diode.
Correct, light emitting diode. What does the abbreviation FET stand for?
Field effect transistor.
Ding ding winner, field effect transistor is correct. What are the names of the 2 electrodes of a diode?
Anode and cathode.
You got it, anode and cathode. What is the term that describes a device's ability to amplify a signal?
Is that gain?
That is gain, correct. What is the name of an electrical wiring diagram that uses standard component symbols?
That's schematic.
Schematic is correct. What is the component number 1 in figure T-1? What is the number 1? What component is that?
Resistor.
That is a resistor. What is component number 2 in figure T1?
Is that a transistor?
Correct, that is a transistor. What is component number 3 in figure 1?
A lamp.
The lamp is correct. And what is the component number 4 in figure T1?
A battery.
A battery, or specifically a multi-cell, because it has multiple cells in it. What is the component number 6 in figure T2? So this guy here.
Capacitor.
Capacitor is correct. What component is figure 8 in figure T2?
An LED.
An LED, because it's a diode with the little arrows pointing out. Light emitting diode. What is the component number 9 in figure T2? This guy right here.
Variable resistor.
Variable resistor is correct.
Notice how the lines come to a sharp point. That's in contrast to number 4, where you have a kind of a rounded edges.
Yeah.
4 is an inductor, and 9 and 7 are resistors.
What is a component number 4 in figure T2? So you got
Transformer.
two inductors with something in the middle of it is called a
Transformer.
transformer is correct. And this takes the AC voltage in and will reduce it or step it up depending on the ratio between these two. So you'll have AC in, and then the diode only passes one direction, so you'll have AC or DC coming out. What is component number 3 in T3? This guy right here.
A variable inductor.
Correct, variable inductor. What
Yeah.
is
No, back up on that one. This is an antenna tuner. The one capacitor 2 makes a radio happy. The other capacitor there on the right makes the antenna happy. Go ahead, Jim.
You gave it away. What is component number 4 in T3?
4 is the antenna.
Winner.
Now, these symbols may look a little different. Sometimes they don't have the top across it. Each manufacturer will do some things a little different with the symbols, but we got the basic parts of these symbols.
Okay.
Hey, Daniel,
Yes.
on that one, you want to describe to people what you mean by making them happy?
We run our radios at 50 ohms on the output to get the maximum power out. So that capacitor 2 in conjunction with the inductor 3 matches 50 ohms. So it's getting the most of the, getting all the power out of the transmitter that will produce. And then 3 in conjunction with the other variable resistor on the right will get the other capacitor right there will get the power to the antenna. Now, sometimes the antennas are 75 ohms or 35 ohms. They're not quite 50 ohms. So that other capacitor in conjunction with the inductor 3 will match that match that antenna ohmage. So all the power go to the antenna and get off the antenna.
Thank you, sir.
What's the one with the squiggly line? That's just any DC power source?
That's where the signal comes in from the
That's
radio.
just the input.
Yeah.
They just kind of cut it there and says it's coming from
Something
source.
happened before.
Yeah.
What do the symbols on an electrical schematic represent? Electrical components.
But
Which of the following is accurately represented in electrical schematics?
we don't know what the following are.
It's the way the components are interconnected. Which devices or circuits change an alternating current into a varying direct current signal?
Rectifiers.
Rectifiers is correct. What is a relay?
Electromechanical switch?
Activated switch.
An electrically controlled switch is correct.
Jinx. We said that at the same time.
What type of switch is represented by component number 3 in figure T2? What kind of switch is this?
The single pole, single throw?
Single pole, single throw is correct.
Yeah, it has one arm, it has one contact point.
Which of the following displays an electrical quantity as a numeric value?
A meter.
A meter is correct. What component is commonly used to change 120 volts AC house current to a lower voltage for other uses?
Transformer.
A transformer, sometimes called wall warts. What is commonly used as a visual indicator? A light emitting diode. Which of the following is combined with an inductor to make a tuned circuit?
Capacitor.
A capacitor and an inductor make a tuned circuit, correct. What is the name of a device that combines several semiconductors and other components into one package?
Integrated circuit.
Integrated circuit is correct. What is the function of component number 2 in figure number 1?
Does that control the current? Is that
Controls the flow of current is correct.
Which in conjunction will turn the light on or off.
Yep. Oh boy. Hang on real quick. My other battery's running low.
But then it acts like a switch in that case.
Yes, yes.
Is that because it's applying a certain current on the left-hand side, would then cause current to flow between the right-hand side and the chassis ground? How does that work?
Are you there, Daniel?
Well, the transistor takes a 7/10 of a volt to turn on. And if you don't have that 7/10 of a volt come across a resistor into 2, it's not going to turn the light on.
Got it.
So
So
that's,
it's on-off switch, not a variable switch.
yeah.
Okay. Had to grab that adapter, otherwise my other laptop would turn off. Okay. Any other questions on this one? All good. Which of the following is a resonant or tuned circuit? What is a resonant or tuned circuit?
Capacitor and inductor.
A capacitor and inductor connected in series or parallel to form a filter. What is the purpose of a fuse in an electrical circuit?
to protect the equipment in case of a overload?
Yep, to protect
In case of too much current, yes.
too much current. Why is it unwise to install a 20 ampere fuse in place of a 5 ampere fuse? Why would you not want to do that?
Well, first off, you're going to allow 4 times the current, and 4 times the current will create 16 times the heat. It'll cause a fire much faster.
Excessive current could cause a fire. And that is the end of Module C. Any questions on that one? We have one more module and it's not too bad.
I had a question.
Yeah.
So the transformer, would the transformer for like your doorbell be the same thing as a circuit board transformer?
It is very similar, yes. It takes the 120 AC and moves it down to about 16 volts, I think it was, or 24. Yep.
Okay.
Okay, Module 3D. Last one. Okay, Lesson 3D is types of radio circuits. The basic transceiver is a combination of a transmitter and a receiver, abbreviated as XCVR, where the X is equal to the trans and then transmitter. Antenna is switched between the transmitter and a receiver by a TR switch. And there's the TR switch in between the transmitter and the receiver, and a power supply coming into both the transmitter and the receiver. Then out of the TR switch, you have your feed line. Here's the other symbol for the antenna that Danny was mentioning. Notice that it doesn't have the little bar on the top. Transmit receive, or the TR switch. The TR switch allows a single antenna to be switched to the transmitter when sending and to the receiver when receiving. In a transceiver, the TR switch is inside the unit and operates automatically. Transceivers cannot transmit and receive at the same time like a repeater. Here's a basic repeater. It relays signals from low power stations over a wide area, and it simultaneously retransmits received signals on the same band. The TR switch is replaced by a duplexer, which allows the antenna to be shared without switching. So on this side you have the transmitter that transmits signal going out through the duplexer through a shared antenna, and at the same time it's receiving the signals coming in and goes through the duplexer to the receiver, which then converts the speech back into the received signal and feeds the transmitter. What happens during radio communication, the review? Transmitting is sending a signal. The information, voice, data, video, commands, etc., is converted to electronic form. The information in the electronic form is added to a radio wave, and the radio wave carrying the information is sent from the station antenna into space.
No, go back there. The number 2 one, the information in electronic form is added to the radio wave. That's called modulation. And there's several ways we modulate the radio wave with the information.
Okay.
Right.
What happens during radio communication review and receiving? The radio wave carrying that information is intercepted by the receiving station's antenna. The receiver extracts the information from the received wave,
That's demodulating it.
and the information is then presented to the user in a format that can be understood: sound, picture, words on a computer screen, or a response to a command, etc.
And an easy way to remember modulation, it just means mixed. Just think mixed when you hear modulation.
Okay. Adding and extracting the information can be simple or complex. This makes ham radio fun, learning about how radios work. Don't be intimidated. You will be required to only know the basics, but you can learn as much about the art and science of radio as you want. Filters. Circuits that act on signals differently according to their frequency. Filters can reject, enhance, or modify signals. Here are the different types of filters. Each of the filters is the ratio of input to output, and there's more signal or less signal. This is the reject area, this is the pass area, and this is the cutoff frequency at where the signal is half power. This is the frequency going from low to higher. So we have different pass filters. Here's a high pass where it's rejecting the lower parts of the frequencies and passing the higher parts of the frequencies. A band pass rejects the lower part, passes the middle part, and rejects the higher part. That's a band pass. A low pass passes the lower parts, but then it rejects the higher parts. And a notch filter passes the lower parts, but notches out and rejects the middle part and then passes the higher parts.
These are all done with the capacitors and inductors, and the value of the capacitor compared to the value of the inductor tells you what it's going to do, whether it's going to reject the low or the high, makes a mountain peak or valley.
Is that a certain type of capacitor, Daniel, like
No,
ceramic,
you can do it with any capacitor.
including electrolytic?
It's the value of that capacitor compared to the value of the inductor at that frequencies.
Okay, thanks.
Adding information or modulation. When we add some information to the radio wave or the carrier, we modulate the wave. Morse code or CW, speech or data. Different modulation techniques vary different properties of the wave to add the information: amplitude, frequency, or phase. Modulator and demodulator circuits. Modulators add information to the RF signal. Demodulators recover the information. Changing frequency using mixers. Signal frequencies can be changed by combining with another signal called mixing. It's also referred to as heterodyning. Two signals are combined in a mixer. Generates mixing product signals. The sum and the difference of the input signals. Shifts the frequency by adding or subtracting. Different than a multiplier, which multiplies a signal's frequency by some integer, usually 2 or 3. Sensitivity and selectivity are two essential tasks for a receiver. First is to hear a signal and hear only one signal. Sensitivity is a measure of how well a receiver can detect weak signals. Selectivity is a measure of the receiver's ability to discriminate between signals. Preamplifiers make a receiver more sensitive. Preamplifiers are added between the antenna and the receiver. A transverter is short for transceiving converter, or XVTR. It converts a transceiver to operate on another band, usually to a higher frequency. External mixers shift the frequency. Typical examples are an HF SSB or CW at 28 MHz is converted to or from 222 MHz. Or a VHF SSB CW at 144 MHz is converted to and from 10 GHz. Okay, on to the questions. What type of amateur station simultaneously retransmits the signal of another amateur station on a different channel or channels?
Is that a repeater?
That is a repeater station, correct. Which term describes the ability of a receiver to detect the presence of a signal? Detect the presence of the signal is
Sensitivity.
sensitivity is correct. What is a transceiver? It's a unit combining the functions of a transmitter and a receiver. Which of the following is used to convert a radio signal from one frequency to another?
A mixer.
A mixer is correct. Oops, double click there. Which term describes the ability of a receiver to discriminate between multiple signals? That is the selectivity to discriminate between multiple signals. What is the name of a circuit that generates a signal at a specific frequency?
An oscillator.
An oscillator is correct. What device converts the RF input and output of a transceiver to another band?
A mixer. A
That's the
transverter.
transverter.
This
Yep.
is a special type of mixer. It's creating from one band to another band. It's a special type of mixer.
Okay.
Which of the following describes combining speech with an RF carrier signal?
Modulation.
Modulation is correct. What device increases the low power output from a handheld transceiver? Increases the low power output.
An amplifier.
An RF power amplifier is correct. Where is an RF preamplifier installed? It is installed between the antenna and the receiver.
The best place to put that is right at the antenna, so you don't lose any of the signal going down the feed line. But yeah, it's between the antenna and the receiver, and that helps you listen to weak signals.
In which type of circuit is current the same through all components?
Series.
A series is correct.
Yes, because it only has one road to travel down.
Yep.
There's only
path,
one way to get there.
one-way path. In which type of circuit is the voltage the same across all the components?
Parallel.
Parallel, yep. That is the end of Module D. Any questions for Module D? And that is our last module for tonight.
I was just curious about why Module 3D had a bunch of Chapter 5 stuff in it. There's the sensitivity stuff. And
oh yeah, okay. I was trying to think of what area. Yeah, some of these drift a little bit in between. You also notice that we had some stuff, a repeat of
Chapter 2.
Chapter 2 was pulled into here. So yeah, I just went with what I pulled down from the ARRL. So I minimized the amount of work that I had to do on this. But yeah, it did look like there's a little bit of flow between the modules. So I will stop sharing this.
Can you explain again the difference between a mixer and a transverter?
Well, a transverter uses mixing to create the higher frequency, and the transverter selects that higher frequency to change the signal up and down. So the transverter is using a mixer to change frequencies, but the mixing is only part of what the transverter does.
So
that make sense?
Yeah, that helps. Thanks.
So I happen to have an HF rig, and I want to communicate on a VHF and a UHF signal. So what I go out and buy is a transverter that transverts from my HF and it moves it up to VHF or UHF.
Where we see these devices used is in satellites. Satellite operation, because you got satellites and 2 meters and 440, so you use the transverters to get up to that frequency. Go ahead, Jim.
Yep. Any other questions? We're bumping up on that magic hour.
Perfect timing.
So let me do this real quick. Let me post this one more time in the chat. So all of the class videos I'm moving over to my YouTube channel. So I will post this sometime tomorrow. And you guys can use it to review if you want to review it or send it to your other friends and say, hey, here's the class I'm taking. And I wanted to ask, because there were some people in the extra class that said, you know, can we move the class a little bit earlier? What would the consensus say if I move this from 8 o'clock p.m. Pacific time to 7 o'clock p.m.? Would that be thumbs up or thumbs down?
7:30 would work, but 7 o'clock wouldn't, because we have some stuff down here with other amateurs for Mike and Key, for Fox Island. So we're done by 7:30.
Okay.
I've got a net at 7:30 till 8, so it's gonna be tough for me.
Well, so I'm also okay, let's do it one more time and hold up your thumbs up or your thumbs down, and let's see where we stand.
I'm
So
not
thumbs
sure.
up for keeping the time as it is.
Yeah, keep the time as is. Okay. So it looks like we're keeping it at 8 o'clock. It looks like okay. That's all I wanted to do, because in my extra class there was a ton of them, and they all said change it. So I went ahead and changed it.
They wanted to go to 7 o'clock, so.
Yeah, and that's on
But that was during
Thursday.
the week. That's Thursday.
Yep.
Yeah, sorry, George. Guess you're staying up till 1.
You missed Coast to Coast with George Norrie. Sorry.
Well, it's not just George. Elaine is there too.
Yeah, real good either way. I'm trying to keep her up. She's
I have
dying to
work
sleep.
in 5 hours, so.
Oh,
Oh my gosh.
all
It's
right.
all good.
I'm going to stop the recording. Thank you, everybody.